Great day, students! For today, we are going to discover and learn new things about science. Are you all ready? Great! In this lesson, we are going to tackle two interesting topics, which are the ecological succession and climate change. In addition, I, Justin M. Zulina, together with my group mates, namely Ms. Wesley Jane Torred, Ms. Shaira May Ruluna, Mr. Mark Junel Susmenia, Ms. Legion Sarmiento, Ms. Josabel Ramos, and Ms. Abigail Ronquillo will give you brief and concise discussion about these topics. The main objective of this lesson is that at the end of the discussion, the students will be able to first, identify what is ecological succession and climate change. Second, to determine what is the growth form and succession. And third is to describe what are the effects of climate change to the Mother Earth. Lesson 1. Ecological succession. But before I am going to discuss about this topic, who among you here can define what is ecological succession? Okay, Ms. Sarmiento? Very good. Ecological succession is the progressive and predictable replacement of one type of community by another over time. There are two major types of ecological succession. Number 1, the primary succession, and number 2 is the secondary succession. In the secondary succession, it consists of 3 stages. First is the pioneer species, second is the several communities, and third is the complex community. First type of ecological succession is the primary succession. Primary succession is the initial colonization of a bare landscape, significant ecological disturbance such as the volcanic eruptions. Examples include areas where lava recently flowed, a glacier retreated, or a sand dune formed. The second type of ecological succession is the secondary succession. It occurs where a community has existed previously but has been removed from a landscape. For example, is an area of deforestation or abandoned cropland. Pioneer species are the first to make up the community within a bare landscape once their seeds or spores migrate from surrounding areas and successfully germinate. The best examples for this succession is the bacteria, fungi, and mosses. Several communities. It is developed in the area after the pioneer community. These transitional communities consist of intermediate-sized species such as shrubs and heaths, which have high biomass and high nutritional content. These species further build the soil and nutrients with biochemical cycling. Climax community is the stable, self-regulating biotic community, which established after many years. It contains longer-lived and larger species with high niche of specialization, complex food webs, and mature interdependent relationship. Diversity is the highest within climax communities, and the community is at equilibrium with the habitat and climate. Our next topic is all about growth form and succession. As we can see in this area in left side, it shows the process on how ecological succession occur. First, from aerial weeds to perennial seeds and grasses until it became shrubs to young pine forest, and lastly, it became a oak hickory forest. It means that the communities may also be characterized by their successional stage. Second, it also means that a community can be described by major categories of its growth form. For example, the mosses, herbaceous, plants, shrubs, or trees.
Stratification. At this natural climax, communities usually exhibit some form of stratification, by which the population that make up the community are distributed into vertical or horizontal strata. Those are the colonized by the finer species, example moss. Decomposition creates the layer of topsoil, grass grew and displaced the finer species. More nutrients in soil allow for shrub growth, and increase in soil depth allows for growth of trees. For example, the bottom-up stratification of a forest community could be divided into 5. First is subterranean layer, second, the forest floor, third, the herbaceous vegetation, fourth, the shrub layer, fifth, the canopy layer, which means the subterranean layer or the subterranean environments are characterized not only by the continuous darkness but also by those variability in a number of specific abiotic conditions such as moisture, temperature, water chemistry, as well as by the isolation of restriction and space. Second, the forest floor. It is often located with decaying leaves, twigs, fallen trees, animal scab, moss, and other detritus. The forest floor is where recycling occurs. Fungi, insects, bacteria, and earthworms are among the many organisms that break down waste materials and ready them for use and recycling throughout the forest system. Third, the herbaceous vegetation or herbaceous plants are non-woody plants, such as most ferns and grasses which either form tiny amounts of hard body tissue or none at all. Unlike woody plants such as trees, these plants don't have a stem that will remain above the ground when their leaves die. Fourth, the shrub layer. It is characterized by woody vegetation that grows relatively close to the ground. Bushes and brambles grow where enough to light passes through the canopy to support shrub growth. Fifth, the canopy layer. The canopy is the layer where the crowns of most of the forest trees meet and form a thick layer. It is also made up of the overlapping leaves and branches of the trees in the rainforest. Organisms may not occupy only one stratum, moving between the layers to feed on a diurnal basis. Example, a bird that feeds to the forest floor during the day but runs within the canopy. A community may occur along horizontal stratification, where there is transition between successional stages and ecotons.
Let us now turn our attention to the topic of ecotones. Let's start with the origins of the term ecotone. The word ecotone was coined from a combination of eco plus tone from the Greek word tanos or tension. Ecotone is a place where ecological areas are in tension. Communities occur in a range of different sizes and the boundaries of each are often not well defined. An ecotone is a transitional area between two biomes where communities meet and may integrate. If the boundaries are wide, it is known as an open community. And if a community in which the species all have similar geographic ranges and density peaks, resulting in a discrete unit where the boundaries are well defined, is called closed community. So now let us deeply discuss what is an open community and closed communities. Open communities are more common in areas with a lengthy environmental history. For example, the slope of a mountain. Closed communities form if the vegetative structure or physical environment abruptly changes, such as an area of a beach that divides the water from the land. As you can see, ecotone is on the zone of transition along the edges of two adjacent equal communities.
Let's proceed on climate change. By the way, I'm Abigail Piranquillo who will report it. Now, what is climate change? It is a long-term change in a statistical distribution of weather patterns over periods ranging from decades to million years. Greenhouse gases are those that absorb and emit infrared radiation in the wavelength range emitted by Earth. Greenhouse gases are essential to our climate. We have evidence of climate change comes from many different sources. We have Glaciers are melting away. Number 2. Ice cores yield information and actual samples of Earth's vast atmosphere. Number 3. Tree-ring data show a warming trend. And the last one is, animal and plant life is changing. Do you know that the result of this climate change is global warming? It is the long-term heating of Earth's climate system observed since the pre-industrial period between 1850 and 1900s due to human activities, primarily fossil fuel burning, which increases heat-trapping greenhouse gas levels in Earth's atmosphere. Greenhouse gases are essential to our climate change. It is because planets with abundant greenhouse gases are very hot. The greenhouse gas content of the atmosphere is being altered by human activity. Number 2, planets with very little greenhouse effect, either very cold. Planets with very little greenhouse effect are either very cold. Number 3, a number of greenhouse gases occur naturally in the Earth's atmosphere. Last but not the least, with no greenhouse gases at all in our atmosphere, scientists estimate that Earth's average atmospheric temperature would be about negative 18 degrees Celsius or about degree Fahrenheit.
Who creates greenhouse gases?
First of all, carbon dioxide. Carbon dioxide in Earth's atmosphere has risen about 30% since the beginning of the Industrial Revolution. Most of the increase is due to the combustion of fossil fuels, which releases the long-stored carbon dioxide back into the atmosphere. In the distant past, Earth was much warmer high level of carbon dioxide in the atmosphere fueled lush growth, some of which was stored in the form of fossil fuels. Because of carbon dioxide, our global is warming. No, that's why global warming is now we experience or we feel right now.
And also nitrous oxide is produced by cars, by fossil fuels used for heat and electricity, and by agriculture. And also methane. Methane is released by coal mining, landfills, and by agriculture, particularly through the digestive process of beef and milk cows.
What we can do to help our Mother Earth. First is heating and cooling. There are 6 ways of heating and cooling on how we can restore our Mother Earth even in a simple ways. First is install programmable thermostats. Check and repair weather stripping doors and windows. Second, adjust your clothing instead of thermostats. Third, keep furnace and AC filters clean. Fourth, consider closing of unused rooms. Fifth, install insulated drips. Last is plant deciduous trees on the sunny side of your home. Second process is conserve hot water. There are also 6 ways to conserve hot water. First is install low flow shower heads. Second, take shorter showers. Third, install a blanket on your hot water heater. Fourth, insulate hot water pipes. Fifth, only run the dishwasher if it's full. Last is wash laundry in cold water.
Conserve in the cart. First, plan ahead to do several runs in a single trip. Second, walk or bike. Aside from its healthier, walking or riding a bicycle can reduce production of carbon emissions. Third, clean out the junk in the trunk. Storing a tons of junk in your trunk actually makes your vehicle slower and therefore less fuel effective. Keep it light back there to make the most of your mileage. Fourth, make sure your engine is properly tuned. It can reduce exhaust emissions. Fifth, keep your tires properly inflated. Just as properly inflated tires are important to saving your mileage and emissions, servicing your vehicle keep it running effectively, which is always the better option for the planet. Lastly, carpool or ride the school bus. Transporting more than one person in a car is always better for the planet than transporting just one person. Cars equal less greenhouse gas emissions and less fuel needed.
We can also help by reducing our waste. Number 1, recycle and buy recycled products. Number 2, choose the products that have less packaging. Number 3 is reuse, repair, or donate. Don't buy it unless you really need it. So the number 4 is carry cloth bags when shopping. So the number 5, choose a refillable travel mug or water bottle. Number 6, always keep your trash with you or throw it in a proper garbage can. The last one is conserve gas. Number 1, unplug chargers or cell phones and other appliances when not in use. So the number 2, get in a habit of turning lights and appliances off. Number 3, vacuum the coils on the back of the fridge monthly. Number 4, change the compact fluorescent bulbs. And then the number 5, make your next computer a laptop. And then the number 6 is install timer or motion sensor on outdoor lights.